To the course Módulo de Competitividad 10, code number FG708. Now we are on week number 11. The topics for today are: first, how to dilute concentrated solutions. Second, importance of water for humans, animals, and plants. Third, family food production. This is Elio Ochoa. Let's get started. As always, we have here our class objectives, and the number one is solve some problems related to dilute concentrated solutions to obtain a new solution with less concentration. Number two, analyze because water is very important for life of people, animals, and plants. Number three, learn some topic of family food production. In our last class, we were solving this problem, but we didn't have enough time to finish it, so let's continue. Suppose we can harvest rainwater using the roof of our house, and we are going to store it in a 1,200 liter container. In order to drink this water, it is necessary to disinfect it first. To make the water drinkable, we need to add 1 part per million or 1 ppm of chlorine. Chlorine is available at the store at a concentration of 3.5% into 100 millimeters of plastic bags or bottles. And the question is, how much of this chlorine should be added to the 1,200 liter tank to bring the mixture to 1 part per million? Let's go ahead. To solve this problem, we can use this formula that we have here, and it says that the parts per million will be equal to mass solute divided by mass solution and multiplied by 1 million. Remember that this scientific notation here means 1 million. Go ahead. This is a real-life application. So in our problem, we have that the ppm is equal to 1. Mass solution is equal to 1,200 liters of water. So our unknown quantity is mass solute that will be assigned next, like one, to identify our unknown quantity. So we need to isolate our unknown quantity, and we will be using the formula like this, and we're going to say that ppm will be equal to our unknown quantity divided by mass solution and multiplied by 1 million. So we will have that our unknown quantity will be the ppm divided by 1 million and multiplied by mass solution. In other words, our unknown quantity will be equal to ppm divided by 1 million and multiplied by mass solution. So if we substitute the values into the formula, we will have that 1 divided by 1 million and multiplied by 1,200 liters of water. But we need to express 1,200 liters in grams. Remember that 1 liter is equal to 1 kilogram and equal to 1,000 grams of water. So 1,200 liters are multiplied by 1 kilogram divided by 1 liter, and 1 kilogram is equal to 1,000 grams, and the result will be 1,200,000 grams of water. If we make all the operations here, we will get that the quantity of required will be 1.2 grams of chlorine solute. It means that we will need 1.2 grams of chlorine solute to disinfect the water. We have the commercial chlorine that comes with 30.5% concentration. This means that this chlorine is diluted, and we need to calculate this relationship as follows. For each 100 millimeters of this solution, we have 3.5 grams of chlorine. How many milliliters of the chlorine solution do we need? Let's continue. So if we continue solving the problem, we will need the to make these operations here. We know that 100 millimeters of chlorine solution contains 30.5 grams of chlorine solute. So if we multiply this quantity by 1.2 grams of chlorine, we will get the solution that will be 34.29 millimeters of chlorine solute. Where we can get this chlorine solute? Okay, as I mentioned before, we can get this product on the store, and we can use a Populino to get the chlorine. So this is the solution of our question here. Now we have an example of how to dilute a concentrated solution, and we have another problem here. If I want to preserve some carrots on a solution of vinegar with a 25% concentration, if I have volume 1 equal to 100 millimeters of vinegar with a concentration of 30%, determine the volume V2 and water in millimeters or ml to use and mix with the vinegar to get the 25% required. Use the formula percentage 1 multiplied by V1 equal to percentage 2 and multiplied by V2. If we identify our values, we will have that the percentage 1 is 30%, V1 equal to 100 millimeters, percentage 2 equal to 25%, and our unknown variable is V2. So substituting values in the formula, we will have that 30% multiplied by 100 millimeters will be equal to 25% multiplied by V2. If we isolate V2, we will get this formula here. V2 will be equal to 30% multiplied by 100 millimeters and divided by 25%. We will get the solution of these operations, and we will obtain 120 millimeters. So it means that we will need to add 20 millimeters of water to the previous volume of 100 millimeters to obtain a total volume of 120 millimeters of final volume. So this is the way we can solve this type of uh, problems. Let's continue. And now we're going to talk about the importance of water for human beings. Water is vital for life and health. It makes up about 60% of the human body and is involved in many important functions, such as transporting nutrients and waste, regulating body temperature, lubricating joints, and creating saliva. Water also helps maintain blood volume, circulation, and viscosity, which are essential for the proper function of all organs and tissues. Without enough water, the body can suffer from dehydration, which can cause fatigue, headaches, confusion, kidney stones, constipation, and even death. Therefore, it is important to drink enough water every day to replenish the fluid that is lost through urine, sweat, and breathing. Water content in human organs. We can see this picture where there are some amounts of water that every organ in our body contains. And we can see that brain has the higher amount of water. So brain is the organ that stores more water in our body. Then it is the heart. Next, we have the lungs with 80%, the teeth with 10%, our liver with 73%, the bone 22%, kidney 80%, muscles 33%, skin 71%, and blood 79%. So this is only a reference that I found on the internet, and let's continue. How much water do we need daily? Water for humans need daily is a common question that depends on various factors such as age, health, activity level, and environment. According to the US National Academies of Sciences, Engineering and Medicine, an adequate daily fluid intake is about 3.7 liters for men and 2.7 liters for women. But this includes fluids from water, other beverages, and food. About 20%